Okay, hello everybody. My name is Paul Craig. I live here in Singapore. I'm originally from New Zealand, and I've pretty much spent my entire life hacking and breaking things. People who know me fondly will call me the most offensive person that they know. Now, today I want to talk about local privilege escalation. Actually, what I want to demonstrate to you are the really simple, subtle little hacks, the little tweaks that are usually very successful when you compromise a system. Now, first of all, I'm going to introduce what is actually the concept of local privilege escalation. So let's take this example where we have these three characters. We've got a king, a duke, and a pauper. Now, we're the pauper. We've managed to hack a system, but we're a very low-privileged user. We don't have much access. And we have the duke, who has quite a lot of access, and we have the king, who's root. Now, the king, of course, he can do absolutely anything he wants. He's the most privileged guy in the kingdom. But he doesn't accept orders. He doesn't listen to anyone, particularly the pauper, but he will listen to the duke. So you can say that the king has an access control. He'll basically deny all, but he'll accept duke. Then if we look at the duke has a close relationship with the king, and the duke has a responsibility to the people, so that he will listen to starving people in the kingdom. He will listen to their pleas. He himself has very limited privileges, but he has very powerful friends. So his ACL, accept the hungry, but deny everyone else. Then, of course, they have us, the pauper, right? We're the guy with absolutely no access. No one looks up to us. We can't do anything. We can talk to the duke, but that's really it. The king doesn't even know we exist. Now, the catch here is that we want the king to do something. Okay? So, how does this work? So the pauper basically says to the duke, hey, I'm really starving. Can you find out what's in etc shadow for me? The duke will say, hey, shit, you're starving. I listen to starving people. You fit my access control. I'll pass this message on to the king. And the king returns then and says, okay, well, I listened to the duke. Here's the information. But if the pauper went straight to the king, he wouldn't get anything back. So this, in a crux, is really all what local priv-esc is. It's about leveraging control. It's about finding out what we have and then just trying to tweak it and find a way around it. So first, we have to understand what our access control scenario is. We have to do a bit of a gap analysis, and then we just got to leverage it. So if we start with the things that can be secured on an operating system, here you have Unix, Linux systems, and Windows systems. Obviously, on a Unix system, it's quite straightforward because everything has a bit mask representation, and everything has a file system representation. From the CPU, memory, disk, processors, sockets, all of these have this bit mask. Now, on Windows, you can see that we've got lots and lots of different ways of doing stuff. It's actually quite crazy. It's a bit chaotic. So we immediately see that there's a bit of a discrepancy in terms of things that we can leverage on Windows platforms. Now, to start with some easy ones, start with some easy ways of getting priv-esc systems. So on a Unix system, when I get shell on a Unix system, I'm almost always an unprivileged user. As an unprivileged user, the first thing I do is I try and find files which just have a really shitty bitmask set. I mean, this is just obvious commonplace. Now, you might think, firstly, that sysadmins wouldn't do this. They do. Vendors do this. I've seen the likes of IBM do this. For large banks, for large enterprises, this stuff actually exists in the real world. I've got an example here from Gen 2, which had world-readable permissions for a log file which contained sensitive information which you could use to get other access onto the system. So you can see how this sort of goes. Now, sudoer files or suid files. So sudoer and suid is a way for Unix systems to have a file run as another user. So let's say I'm the user nobody, and I want to run a privileged file. If I mark it suid and have it owned as root, when I run that file, it'll actually run as the root user. So obviously, there's a lot of leveraging here, right? Because I can get the king user to directly run something. So there are a lot of published vulnerabilities of suid binaries that have, accept an input which can be a file somewhere else, which could be a privileged file, which you could read. They take in a command, or even environment variables. And I got a few interesting examples here for you. Here's a code snippet from a change password program. Now, this change password program is actually horrendously flawed. For the sake of time, I won't ask anyone to try and solve the vulnerability here, but essentially what it's doing is using a local subjective environment variable on the system. So if we look here, the application, which is marked SUID, reads an admin path environment variable, and then calls a binary which it considers to be in the admin path directory. So as a user, if we just run the command at the bottom, export admin path as temp, and then copy bin bash to temp change password, then run admin tool, it'll run as SUID, and bang, we get bash as an admin. See, it works, right? Now, what about this? This is Nmap. So when you use Nmap and you want to do a SYN scan, you need root. You need privileged access, right? So if someone gives you a laptop and says, hey, we want you to try and hack our systems or something, and using this laptop, usually they have to mark the Nmap binary as either SUID or put you in the sudos group. However, with Nmap, you can actually get shelled directly. So here we have Nmap. We can see it's sudo, so the user that we are will run Nmap as root. And what I do is create a script, a little Lua script, which runs a shell. I then run Nmap, which runs a sudo, which runs the script, which pops the shell. So very, very simple little chain of events, but I go from UID 1000 to UID 0. Bang. Now, this is something that you'd think probably definitely wouldn't exist, but again, this still exists in production, which is that you can have users' home directories, which is just horrendously insecured. So you can have files which are writable, which shouldn't be writable. You can have a service which has a home directory, which allows a file upload into a directory where you can write like a bash profile or a bash login. So when the user logs in, then it'll execute your command. You get the privesc. We can also just have files on the system which contain the passwords. I mean, it really is as simple as this. So vendors love having a file somewhere which will contain a password or a password in a script or something like this. So usually when I get shelled, the second thing I do is just to go through and try and find any configuration file, any backup file, any file of interesting value. I then pull the content out of it, and hey, look, you got a password. And common one is to grab a database password. So we look for like web configuration files, web.config, global.asa, things like this. And then when you can log into the database, you're actually running or connecting to the system as the database user. Then you use the database to execute a store procedure to run a command. And then now you've privesced to the database. Now here's something that's a little sneaky. When you run a tool in Unix, the command line arguments to that tool are visible to all users on the system, all right? So in this example, you can see at the top, I've got MySQL-H-U root and then -p a password. So the sysadmin has ran MySQL with the password in the command line argument. Only every other user, if you constantly type ps-aux, you'll see the password. Now, there's an easy way to do this. There's a little tool I found called Snoopy Logger. So it'll run as an unprivileged user and just log all of the command line arguments that are passed to every binary that executes on the system, and then give you a log so you can look at it. Now, I Googled for just how many man pages contain the -- password argument, and I got 28.6 million. So most tools actually have this option. So if the sysadmin's doing it wrong, it's really easy to just steal his password. He'll give it to you. We can have weak permissions on cron jobs, so scheduled Unix jobs, or the dependencies of a cron job. Or we can actually have vulnerabilities in the environment of the cron itself. So in this example, the developer has set, or the sysadmin has set the path to be opt vendor bin opt backup bin, USRS bin, sbin bin. So when they run the tool backup tool, the system will look first in opt vendor bin backup tool, then opt backup bin backup tool, then USRS bin backup tool to find where the tool is. Only if the file exists in opt backup bin, we can write it into opt vendor bin, and then bang, next time this cron runs, we prevesc again. Many, many, many ways to do this. Or we can just have incredibly terribly designed software. So this was a vulnerability that came out recently in a security product which checks for rootkits. And essentially, in the code, if the file temp update exists, then run it as root. So you want shell, you just copy your shell to temp, update, and bang, it gives you a shell. We can have malicious symbolic links and hard links. So symbolic links in the Unix file system is essentially a file which is a pointer to another file. A hard link is a file which is a pointer to the inode of the file. So any user can create a symlink to any other file on the file system, regardless of whether or not you have access to that target file. Right? And this creates quite an attack avenue, as seen here with the sendmail vulnerability. This was quite an interesting one, where basically if you create a hard link to etc password with the source of var temp dead letter, when you connect to sendmail and try and deliver mail to a user that doesn't exist, it will write it into var temp dead letter. But var temp dead letter is now a hard link to etc password, so you end up writing content into etc password, bang, you're root again. Now, that's sort of exploiting the Unix world. When you're doing this on Windows platforms, it's actually really different, really, really different. I find Windows much more fun because it's more tricky. You've got to be far more sneaky. So firstly, on the Unix world, if you want to prevest, the first thing most people will do would be go to exploit.db and you search for the kernel version. Is there a kernel exploit? Compile the exploit, run the exploit. Only on Windows platforms, we have like Patch Tuesday, Patch Thursday, Patch Friday. This stuff doesn't exist. You can't just do this on Windows. If they have Windows Update, it just doesn't work. If you get really lucky, you might find there's third-party software which runs as a privileged user, which has an exploit available, but that's really getting quite lucky. This is not the avenue for Windows. This just isn't how you do it. So how do you do it on Windows? Now, I decided to do a little bit of an experiment. I went out and I downloaded a whole bunch of kind of crappy vendor software. Just software that was out there that your average person might download. And I started picking on this company called Aimersoft. Aimersoft creates software for DRM conversion. So if you have like a DVD that won't play in your region, Aimersoft will decrypt it and allow it to play for you. So I decided to figure out how secure this sort of software is. So first thing I did was I ran Sysinternals access check, and I looked for files in the file system which were world writable. So everyone has full control. No matter what user you are on my system, if you're on my system, you can modify these files. Sure enough, I found Aimersoft. Wow, I can modify actually quite a few of their files. Okay, so this starts getting a little fun. So I can overwrite components of this application very easily. Then I started looking around and I realized actually this is a really common vulnerability because most software vendors have suffered from this, including Steam and Ubisoft, some of the two largest game platform companies in the world. So if you use their software, hey, actually you have a local prevest sitting on your desktop where anyone can overwrite the files that it installs. Now we have the same thing for Windows services. Would you be surprised to know that the Cisco VPN service had a very nice exploit where basically the VPN service daemon was world writable. So anyone on your system could just overwrite the Cisco VPN daemon, and then the second you try and VPN to your work, hey, actually you're running their exploit. You wouldn't even know it. Yeah, what the fuck's this? This is a security software vendor. It just doesn't make sense. We can also do things like reconfigure a service on Windows. So because everything on Windows has an access control and can be configured, the service itself has an access control that allows the service to be reconfigured. It's called service change config. It's actually not uncommon to find services which allow you to reconfigure them. So if you can reconfigure a service, you say, well, instead of running the binary that you want, actually, you're going to run bin path netuser hacks add. And then add hacks to the group administrator. Now I'm an admin. Again, very easy. And this stuff, it really, really surprised me. I went through quite a bit of vendor software, not just Amersoft. I found so many of these vulnerabilities. 0 day after 0 day after 0 day after 0 day. Now, does anyone here use any of these applications? There's quite a few, right? Firefox, Internet Explorer, Chrome, Flash FXP, Real VNC. All of these applications store your password in a recoverable format in the registry. A lot of them actually store it as a world-readable value in the registry. So, I mean, it doesn't really get too much easier than that. Now, back to Amersoft. I started playing them with the registry registry keys that Amersoft uses. And I found that, it also has quite a few problems because all of its registry keys are world-writable. World-readable, world-writable. And then I started thinking, like, how can I leverage this? How can I break this? So firstly, we see the app version. Okay, so I can change the application's version as any user. exe path. Okay, so inside the executable, if you want to actually do the media DRM conversion, it will call exe path as the binary to run to do the conversion. But that value is world-writable. So you just change this to unc path, like / malicious IP / shell.exe. And the second that you try and convert the media, it will download and run your evil shell. We also have this uninstall jump page, you see. So it's a page you go to when you go to the Windows add remove software. And then it says, like, oh, we're very sorry you removed Amersoft products. Could you please give us feedback? Only this key is also world-readable and world-writable. So we can change this to, gee, I don't know, if you have Skype installed, we could have call to : plus number in the Congo, which costs you $300 to call. We could have a UNC path. We could have a file system path. We can pretty much do anything. It'll just open this location. Fun. Now, orphan files. Orphan files are a really good way of getting more privileges on a system because these are files that don't exist, that have a pointer to them, running them at startup. So you can see on this system that I reviewed, the Dell System Direct tool at some point was installed and then deleted or uninstalled. However, the uninstaller script didn't remove the run link. So every time Windows starts, it tries to run this. Only this file doesn't exist. So you drop your shell into this location. Next time the user logs in, bang, now it runs. We can also do what's now become quite a common trick called Dll Hijacking, which is basically equivalent to the Unix crontab path environment vulnerability that I showed, where Windows applications will look for DLLs in certain directories. First, if they don't find them where they should find them, it tries to look for them. So back to Amersoft. So when I run Amersoft, you can see at the very top there, it tries to create files, C programs files, x86, common files, Amersoft helper compact, wsop32.dll. And this isn't where that file exists. Only because this directory is world-writable, I can just drop a file there. And then I have another exploit in Amersoft. So I've got so many frickin' ways to priv-esc a user through shitty DRM conversion software now. And Windows has the ability to just mark what's called install always elevated. So install always elevated means that if this is set and any MSI file, so any installer package, when you run it, will run as an administrative user. So although this isn't enabled by default, this is commonly enabled on enterprise laptops because remote software administration, like your IT support team, need to be able to run and install updates for other products, and they need those to run as an admin user. So for those of you who work at enterprises here, if you ever want to actually just priv-esc your own laptop and get the admin that they won't give you, just run an MSI file. All right, so that was my brief foray into local privilege escalation. I don't recommend anyone here gets into using Amosoft software. I'd just like to point out that in 2016, there seems to be an unlimited number of ways to actually priv-esc software, from big software vendors like Steam, like UBIsoft, to security product vendors like Cisco, to shitty desktop software. I mean, this is absolutely everywhere. Everyone seems to have no idea how file system permissions work. Now, are there any questions?
Okay, so any questions from the floor? So may I repeat? Any questions from the floor? So if no, then we thanks Paul.
Alrighty, thank you.
Thank you very much.